So this is it, the system we'll all be talking about today. The robot cell that was already something special when it was created. Welcome, dear viewers, live from the production hall of ALLMATIC Fastems GmbH in the beautiful Allgäu region. For 1 hour, you will be able to join us for a look at the development and realization of this very special manufacturing solution. And of course, we'd also like to show you what possibilities and potentials automation could offer you, in terms of unmanned loading, but also with regard to producing small batch sizes and the pressing issue everywhere, employee shortage. I look forward to a truly exciting discussion with the following participants.
Hello, my name is Herbert Meyer. I'm the Managing Director of ALLMATIC Fastems. I was responsible for the investment as operations manager at the time, from planning through to implementation. I'll also tell you what the system has to do with two thick planks later on. Hello, I am Thomas Weinhold from Fastems. I work in sales and partner management for automation products and solutions in the European region. If you are curious about what a beer coaster has to do with an automation system, please stay tuned. Hello everyone, my name is Christian HELLER. I've worked for HELLER Maschinenfabrik in Nürtingen since 1993. I've worked in various positions and departments there and have been with the automation department for about 8 years. I'm responsible for preparation of quotations and project handling. Although HELLER has already implemented a number of automation projects, it's often the details that turn out to be the big challenges later on. And that's exactly what happened with this project.
We've made ourselves at home down here in the production hall, as you can easily hear. But please don't let the noise disturb you. We deliberately want to keep the robot cell running in the background, so it can get a little noisy now and then, but that doesn't matter. We'll manage. A little hint for you. If you have questions during this live broadcast, drop us a line in the chat window below this video. We will try to answer some of the questions at the end of this live broadcast. Any questions we can't answer today, we'll try to respond to later by email. Well then, let's get started. Herbert Meyer, as Managing Director and our host here in the ALLMATIC Production Hall, I'd like to know how the three of you came together as partners in the first place. But before that, I'd like to know, what is it we're talking about here today? What is the robot cell? What can the system do? What's it used for?
Well, as you say, we can hear it working away in the background right now. It's working. That's great. Nevertheless, I'd like to show you a video to make it easier for you to understand the process steps.
Great, then let's have a look.
Well, it starts with our young employee loading the machine with the raw material, a saw cut. Black pallet means raw material. We'll get to the white pallet later. This is the finished material. This is where the pallet is loaded. The complete pallet goes into the system. Then the shutter door closes. The operator calls up the program. The program contains the tool data, subroutines, everything that our master computer needs to process the job. Then the magnetic gripper comes in, picks up the component, and places it onto the re-gripping station to position it. You can see it right here. Then it repositions and places it into the gripper to have it in the right position. Then it transfers the part into the system where it is clamped. Now you see a small montage where the part is already finished. It now performs the unmanned changeover. During this process, it takes out a new pallet with our tombstone, which it needs for the next job. It puts it on the machine pallet and changes the gripper again. Then it inserts the raw material. And what you see here is our clamp drive, our newly developed product for closing and opening our tombstones. Without this newly developed technology, it would not have been possible for us to close such a tombstone. The tombstone is then blown off before the new raw part is placed inside. Now you can see the closing process. The robot holds the part until the clamp drive has closed the tombstone. It works the same way with the second setup. The second setup part is stored temporarily. the gripper comes in and again places the component into the tombstone, which is then closed. Now you can see the first setup is already finished. While one setup is machined, the second setup is loaded as part of this process. Now our clamp drive comes in again. The robot is holding the part. Clamp drive opens our tombstone, which is then blown off to remove chips. Then the process continues. It does that either 3 times 120 degrees or 4 times 90 degrees. That means using 3 or 8 clamping stations, and it does all that in the process time. This is where the finished part is blown off. Then we have the process. It can be different for everyone. In our process, the part is blown off and placed near an immersion bath for corrosion protection. First, it goes into a blow-off box to clean it in order to prevent any dispersion throughout the system. Then it goes into the bath for corrosion protection. As you can see, it's lying on top of the immersion bath. Then it's dipped in and rust-proofed. Again, the robot blows off the oil to reduce dispersion into the machine. Then it picks up the part, places it back onto the intermediate station so it can grip it with the magnetic gripper. Using the magnetic gripper, it then places it into the white pallet with the finished parts. Exactly the way the robot has set down the part, the pallet is transferred to the shipping department from where it's dispatched directly for heat treatment. So there's actually no process in between for rearranging or restoring the parts again. As a result, we have a very short process, but it's our entire process.
That's absolutely fascinating. We'll discuss this later in detail. What I would like to know is, how did this idea come about in the first place? Who initiated it? And how did the 3 of you come together as partners?
Well, that's a longer story. There were several reasons, but I'll try to summarize the story. We already had several years of experience with an unmanned shift in production here at ALLMATIC. 2 manned shifts and 1 unmanned shift we ran at night. However, as you gather experience, you get to the point where you start to think about having a second unmanned shift. That was our initial thought. In the end, I only wanted to run 1 manned shift and 2 unmanned ones. There was another reason. At that time, ALLMATIC wanted to, or did, launch ALLLIGHT. ALLLIGHT is a digital division through which we only sell our products online. Everyone knows this from personal experience. When you buy something online, you want it to be available at your house the next day, no matter what. And that was the new challenge, also in production. It's not about building up immeasurable stock levels, but about producing further parts as quickly as possible. So the next thought was, I need to get an order through manufacturing as quickly as possible. Not a wild mix, just this particular job as quickly as possible. That was the second reason. The third reason has been a topic of discussion for a long time in many companies. The shortage of skilled workers is a big issue. Until recently, you may have heard that vacancies were difficult to fill. But meanwhile, it has become such a major concern that it's more and more difficult to fill the positions. And that, of course, was the drive, the idea behind it. I need to be able to produce more without manpower.
And then you went off looking and immediately found the right partners, and very quickly the system was born?
In fact, I didn't go looking straight away. First, I thought about it for many hours and talked to other people a lot. The most important thing for me was to come up with a concept. What does it all involve? What do I have to do? If there are many operations and production managers watching, they will probably all face the same problem. Every company has different parts. Every company has different requirements. And automation must fit the company. For only a few companies, a standard automation will be a fit. I just kept thinking about it. And very quickly, the clamping fixtures came to my mind. How can we clamp the parts? I knew that with our small batch sizes and part variety, I would not be able to work with single vices. That makes no sense, also in terms of process time. And with the online shop, we also face a certain cost pressure that we have to take into account. So it was clear that we had to use tombstones with multiple setups. And I just happened to know a well-known manufacturer. ALLMATIC was to supply the tombstones too. But the tombstones at the time were manually operated. ALLMATIC has a history with mechanical tombstones, but if you want to automate a process, you have to be able to close the tombstones automatically. As a first step, we then started thinking about a design of our own. what could we develop in terms of electronic components to close the fixture? And with these thoughts in mind, I went to visit various automation companies and machine manufacturers, very well-known ones we're all familiar with. Well, they were all eager to sell machines, but my idea was that I wanted and had to perform unmanned changeovers. Because we all know this from production. Sometimes you have excess quantities. Sometimes you have shortages. Sometimes you produce rejects. So how is the dispatcher supposed to manage all that when we're only loading during the day? That won't work. Then it was clear to me that we also had to perform the changeover, not just the production, in unmanned operation. I then told my first contacts about this idea. They rejected a lot of things and said it wasn't doable, technically not feasible, and that their company couldn't implement it. But let me cut the story short. Then came the day when I received an invitation to the HELLER in-house exhibition. I was happy to attend and also have been in contact with the HELLER sales representative, Mr. Langer, for a very long time. I met him again at the in-house event and told him about my idea. Mr. Langer is very industrious. He then immediately arranged a relatively large ad hoc meeting at the event, and I sat down with Fastems and HELLER, with all the experts. Then I presented my ideas again, and that's when the spark ignited. It's difficult, there will be many challenges, but we can make it happen. And I noticed myself that they enjoyed the new technology. That was a real, how shall I put it, men and technology round. We were creating something new.
And that's when Fastems came in. Thomas Weinhold, it's great that the three project partners had already sat down at a table together at the in-house event, but honestly, Mr. Weinhold, when he approached you, or Fastems, with this idea, what did you think? Were you enthusiastic about it right away? Was your reaction, yes, we can do it? Or was it, oh my God, what is he thinking?
Be honest. I am honest. Would you rather leave? It's quite simple. When you start something new, when someone brings up an idea, then I'm the one to say, nice idea, cool idea. How can we solve this technically? What additional challenges are there? And when I think about the group that got together that day, the chemistry was simply optimal. It allowed us to ask open questions. People were able to brainstorm together. All challenges were discussed openly, and that allowed us to follow up on the idea in our organization at Fastems. With that, the whole thing picked up speed again. There were some internal cross-currents in the organization, but in the end, we were able to draw up a concept and presented a proposal saying, look, this could be the solution. These are the challenges involved, and these are the limitations, for example. And then the whole thing was refined further and further. You cannot develop a concept in this form in one day. You can't pull it out of a drawer. You need a few rounds of discussion with everybody involved to build up the whole thing and then come to the final solution. And lots of coffee, of course. Yes, lots of it. Beer didn't exist back then, at least at ALLMATIC.
That's of course also the challenge, because it isn't anything off the peg, nothing you could pull out of a drawer. Mr. HELLER had been a partner from the very beginning, so I'm asking you as well, what was your experience in this? Was it clear to you that it would work, or were there doubts? What were your thoughts when the idea was born?
In principle, we could already see that we would be able to do it. You always have to approach certain topics with the necessary respect, though. And that was also the case with this project. We did look at the screwing technology with a certain respect because we didn't have the experience yet. And in the end, everything has to work properly.
What was HELLER's part in the system we have here now?
We took over general contracting. It means we acted as general contractor for the project. So our task was to bring the project partners together and to lead the project to success. What's important with a project like this, where you have several interfaces in the system, you have to have a good general contractor. Otherwise, everyone will rely on the others to do it, only to find out on the day of commissioning that one of the other parties did their job and the other didn't, because the interfaces don't match. We also organized the whole project together with Fastems and ALLMATIC, bringing the conformities and manufacturer declarations together. These were our tasks.
If we look beyond this project for a moment, what else does HELLER stand for? I mean, we have a professional audience here at the screens, but still very briefly, what else does HELLER do?
HELLER is a manufacturer of metal cutting machine tools. We employ 2,600 people worldwide at 5 locations in Europe, North and South America, and China. We operate 30 sales and service locations. Our product portfolio ranges from 4-axis to 5-axis machining centers in a wide spectrum of designs and sizes. We deliver entire manufacturing lines throughout the world. Our product portfolio also comprises services, of course, which is one of our great strengths. Digitization is advancing rapidly, and of course, automation.
That's your specialization. What does Fastems do in general?
Fastems is known in the market as a neutral automation solution partner, both for pallet automation as well as workpiece automation. The beauty of this cell is that it combines both. And the first challenge was to get that right. Fastems is a Finnish company with headquarters near Helsinki and operates worldwide. Our main markets in principle are Europe, the USA, and China.
ALLMATIC is known as a clamping equipment manufacturer. How would you describe ALLMATIC?
Right. We've been manufacturing clamping equipment for milling machines since 1973. Until recently, these were basically mechanical. And that goes with today's topic. This system made ALLMATIC realize that it is no longer enough to manufacture mechanical clamping equipment. Customers want a complete solution from us, and we have changed that in recent years and now offer complete solutions. If the customer faces a challenge or a problem, then we provide the solution. Whether this only takes our own ALLMATIC products or support from other products, the customer will get a solution from us. And this system has really paved the way for us. We now have to digitize and automate our products and combine them with electronics. To do that, we have expanded our design and development department. For 1.5 years now, we've also been working with universities to develop our portfolio, and more in this direction, because we have recognized the needs of the market, just as Christian said. For the next few years, a single solution could suffice basically. But in a few years' time, systems will become more and more complex, and all the parts involved in the system, tombstones, master computer machines, they all have to communicate. The weak point in the market at this moment is still clamping technology. Clamping technology does not communicate with anything. HELLER and Fastems components communicate, also with our electronic screw unit. But the tombstone itself does not communicate, and we have to change that. But that precisely was the appeal, being able to create a novelty in the field of clamping technology, implemented based on proven mechanical clamping technology throughout an entire automation line. That's something which to our knowledge had not existed on the market at that point. That meant many challenges, but also new territory, new developments, and nothing off the peg.
Would you say that this was also the sticking point with this machine? Was that the focus, the key challenge? Was this the problem to solve to be able to implement such automation solutions?
Yes, I think so. Because with a cell like this, every operations or production manager has different technologies and units he likes to invest in. But in the future, or even now, it's about how the units communicate with each other. But there's more to it. What I found interesting is what Christian said about how big HELLER is. The company operates numerous subsidiaries, locations, service points. Compare that to ALLMATIC. We are located in Untertingau, in the middle of the Allgäu region. We have 60 employees. We neither have the capacity nor the know-how to implement a cell of this kind. We can only do this in cooperation with partners. And just as the partners connect, so must the systems and the individual components. And that, I think, is the sticking point. Finding the right partners and finding the right individual components to reach your goal. But every company and every production manager will have different goals. There will never be a blanket statement.
You've already addressed many topics we'll be talking about more detail later on. For instance, how do you tackle this as a partner? Is it conceivable at all for smaller companies and also for small batch sizes? We'll get to that in a minute. I'd just like to touch on one question again briefly. In principle, You play a triple role in this project. You're the idea generator, the customer actually, but at the same time also a project partner through your own vice. Perhaps we have to mention again that the machine is not only here for demonstration purposes, but it actually solved a problem for you. Maybe you'd like to tell us again, how is it used? What is produced here?
The parts that are produced on the machine now were already manufactured by ALLMATIC before, mainly on single machines. In practice, that means most parts were produced in 3 setups, and the operator had to clamp and unclamp each part individually. Following the discussion round with Fastems at HELLER, I realized something that's a kind of guiding principle to Fastems. They told us that we should not automate a process that we had not mastered. And that really is the key message. First of all, we revised all the processes, all the parts that could be run on the system. As a result, we managed to go from 3 to 2 setups. And we had to do this, otherwise the concept would not have worked. We also revised all the processes, procured new tools, until we had mastered the process. And only then did we dare to automate these processes. And that was actually the foundation before we started into the whole technological process. That's exactly the point that sometimes puts people off in the market. They say, I have my process and I don't want to change it. But this process is not suitable for automation. The advantage with ALLMATIC with Herbert was that he recognized that. He understood it. That was the beautiful thing about this partnership, being able to talk openly and say, you have to make organizational changes if you want to implement the process successfully.
What's the current situation? What's been improved? What's changed now with all this?
Christian, who's very experienced with the technology, gave me some advice regarding my first request, and for all parts in general. The advice was to start slowly. At the time, we discussed starting with 31 components. They all came from the single machine. In other words, we managed to eliminate the 3rd setup for all the parts. And now all components are run without changeover time. Changeover takes place continually, and if anybody does the changeover, it's the machine, but no longer the employee, within the process time in which we produce. And of course, we've also reduced the machine running time and cycle time, because today machines offer stronger performance, and that's why we are faster now. It allows us to run a job within the shortest time from one day to the next, whenever there's a requirement coming in from the online shop, but also for other parts. It doesn't matter whether it's on Monday or Wednesday or Friday, the job runs through to the end until the white pallet in there is filled, as we have seen in the video.
Now it almost seems a little too simple, too harmonious, as if it had been no problem at all. Mr. HELLER, you mentioned challenges, the fact that even the smallest things can often turn into huge challenges. Was that the case with this project as well? What were the challenges?
One was the integration of the screw unit. In the beginning, it was said that integrating the screw unit would not be a big deal, that it would be possible to do it at the company. But I kept saying, you have to approach this with the necessary respect. Nearly from the beginning, it was clear to us that this had to be in the focus from the start of the project, and that we would have to agree on it together. We then immediately organized a workshop in Nürtingen where we met. There were no teams at that point. Not really. We only did that in Nürtingen. We talked through the interface for a whole day several times. Then the next step was to send the screw unit to Fastems so that it could actually be tested on site. And then we had interface workshops for which we used simulators. HELLER has simulators for every machine and every environment. We took the simulators to Fastems in Issum and did the interface tests there. That way you can test about 70% of the functions. For the screw unit, we also set up a demo frame and played through various scenarios. Because Using the normal sequence for automatic operation is always the easy way. But what if the system stops? What happens to this turning spindle? Does it retract without any problem? Can it return to the home position? Those are the issues that came up. Or what happens in case of an emergency stop? Those are the challenges at the end.
Were you able to use standard machines on the part of HELLER, or were there any special requirements?
In broad terms, this is a standard machine. We had to make some changes to the interface because there's a difference between part handling and traditional pallet handling. It also has an interface for the master computer. We clarified all that together in advance. We also have an NC rotary setting station that allows precise straight positioning. The rest is actually all standard functionality. But I agree, it sounds so easy now. Also what Christian said. There's one thing you mustn't forget. We're talking about a period of 3/4 of a year, during which we constantly met with all the experts. And as you say, agreeing on the interface was absolutely crucial. If that hadn't worked, if we hadn't had the same goal in mind about what the interface should do in the end, it wouldn't have worked. In the beginning, there was a lot of skepticism, if it could all be done. That's also why we immediately had our first meeting, I think 3 to 4 weeks after receiving the order, because we knew we couldn't delay the first meeting for half a year. And I have to say, it worked brilliantly. Sure, there are always issues. It would have been a miracle if that wasn't the case. There was always sensible cooperation.
I'd like to go into more detail, Mr. Weinhold. When we talk about small batch sizes, we are also talking about opportunities for smaller businesses. How complicated, for example, is it to teach this robot, to program it? Do I have to do this myself as a customer? How does it work?
Well, we know that robotics has fallen somewhat into disrepute in the market because everyone is hesitant to learn a specific programming language for the robot and having to enter every bit and byte himself. With the integrated master computer function, you have the possibility to easily integrate new workpieces and new grid systems via parameterized control. For ALLMATIC, this was a block-based version in principle, where the entire process is automated by simply setting the parameters. This means I don't have to start by picking up an operating unit for the robot to start teaching new positions. That happens in the background via the master computer. Parameter technology is the keyword. But it was exactly as you describe it. That was what scared us as well. I had respect for something like that, saying that an employee of ours has to be able to program a robot overnight. But that's not how it is, and that's not what I wanted. You simply have to be honest in these conversations. What is a company able to do? I knew we couldn't do that, and I said that from the beginning. Since the system has been running, we have ramped up to 48 different components, and we're doing the programming via parameters. If a part is 10 millimeters larger in the end, then we change our parameters by 10 millimeters. But we're not doing any programming on the KUKA robot. The basic programs come from Fastems, and we have not made any changes since then.
Really fascinating. Now there is something all three of you have mentioned. You have all broken new ground with this project. In other words, something that has not been done before, something that is not and will not be available off the shelf in this form in the future. These are all individual projects. I'd like to ask you all, what is the bottom line for you? What do I have to do for such a project to be successfully implemented when you have three partners working together? What does the success of the project depend on?
I don't know. Maybe it was just the random constellation of our three companies. You need someone who overshoots the mark, who maybe wants things that don't work. You need engineers at the table to bring you back down to earth. What is feasible? But you also need realists. That's the mix. That's what our three companies all had in the end. We realized very quickly what was feasible and what would be critical. and that we would be honest if it became clear that we needed another solution because we might have overshot the mark. The important thing is that the companies know what each of them is capable of, what they have done before, and what they believe they can do. Another aspect to be taken into account is listening and having an understanding of the requirement and the implementation. Many suppliers do not even understand their task and what a customer wants from them. I think we took the right approach at the start. We sat down together and started to understand what the particular requirements were. At the time, we didn't know exactly what a screw unit is. How does it work? No idea. So we listened, learned, and then looked at the solutions together, step by step. Then the attraction was being able to put up the cell here. But that wasn't clear from the beginning. First, we had to develop the concept. You also have to move away from the misconception that a quote for such a project can be prepared ready for negotiation in 14 days. We worked together very quickly, but there were so many questions that needed to be clarified throughout the process. And you have to do that during the quotation stage. If you just sell something, you'll get complaints afterwards. If I had known this and that and so on, it's always bad.
Let's stay with this question. What would be the ideal way to approach a project like this, considering all the learnings that you may have taken from it? What would be the right way to tackle it if I had a similar idea?
I think that's difficult to say. If I suggested this was the ideal way, it would come across as a kind of recipe for success. But as I said before, every company has a different manufacturing philosophy, and every company has different components. I believe you have to dare to live in an idea. You need to have the drive to make a change or to automate a process. When thinking about how to automate, you should be clear about one thing in advance. What parts do I have? What staff do I have, or will I have at my disposal in the future? Do I have several setups, or do I want to go for a single setup? These are the things the person in charge and his team need to clarify with the skilled workers at the machine. That's what you have to be clear about first. Once you've thought about that, you should talk to an automation or a machine manufacturer. Because today, even small companies can or must dare to take this step in the coming years, but no one can do it alone. We mentioned process reliability before. If a customer is unclear about his process and expects an automation company to solve the process for them, that won't work. The machine manufacturer may be able to help support or redevelop the process so that it can be implemented in an automated way, but automation is only a tool in the implementation. And that requires some groundwork. You can do it together, but it's very difficult because you don't know the customer's manufacturing range at that point. Instead, you have to collect ideas and develop a concept, and accept if you encounter resistance because it doesn't work. Maybe I could give you an example to make it clearer. If you have a milling method or tricky parts that require staff to have the know-how of a skilled worker, then it is hardly possible to automate the process from my point of view. You have to be clear about your production and know how many parts you have with reliable processes. Those are the ones you have to single out. They are the ones you can automate. But you can't replace a person with lots of know-how needed for certain parts with automation. That's a misconception. And I'm convinced that you will not be able to automate these processes until you have a solution to make the process reliable without needing the know-how of the employee. These processes will still rely on the staff's expertise.
Mr. Heller, do your customers already consider automation from the very beginning? Or do they buy a machine and then at some point in the future start thinking about automation?
At the moment, it's still the latter. We are still selling some standalone machines that already have a robot interface on board, where the customer says that he would like to add a robot automation at some point in the near future, or in a few years' time. But we've also had specific cases where the customer had already put a lot of thought into what he wanted and opted for automation straight away. We also have customers who don't think about it. As a machine or automation manufacturer, You have to accompany them and put them on the right track, so to say.
Where does this hesitation about automation come from? Is it a matter of company size? Has it to do with the processes? What's your view on this, Mr. Weinhold?
I think a lot of the smaller companies might have the problem of not having the time to think about it in the first place. They are under pressure to manufacture, but don't know how to cope with the masses of parts. They don't have the time to think about how they could approach it in a different way. There are customers manufacturing in a garage, working 17 hours at the machine, and still have to write quotes after that. No one can cope with that. They need a solution to address this issue, and that's where the automation specialist comes in with advice. The company will not be able to do it alone. The time factor is the first issue. The second issue is that they are hesitant about taking the next step in the organizational development of the company, because that involves a relearning process. Changing long-established structures, striking a new path, that's another inhibiting factor. Ultimately, the question is, an automation system increases my investment costs, and in principle, I have to add them to my production costs. Will I be able to handle that or not? Those are the inhibiting factors. Earlier you said that I'm playing a triple role. I assume that means my speaking time is also 3 times longer. I just wanted to add that I believe you have to be honest about it and look at it from a human perspective. There's a certain anxiety involved. When you do something like this, you feel trepidation. You are adopting a new method you're not familiar with. It's no different in private life. When you're confronted with something new, whether it's a new PC, a new mobile phone, new software, it scares us at first because we're not familiar with it. And against the background of this anxiety, you, as the operations or production manager, have to justify the investment to the employees. If it doesn't work out, they'll start looking for culprits. And as Mr. Weinhold says, there's a certain amount of money at stake for the automation. You also have responsibility towards the management in the end. I also know it from my own experience. And if he's listening, our owner was certainly not convinced at the beginning to be able to say, "This is the way to do it." I was sure it would work. But from that, you can see that implementing automation has a lot to do with trepidation.
Now, speaking about anxiety, there's always people who will say that unmanned loading, automation, is a bad thing because it destroys jobs. Do you want people working here to lose their jobs? There's a quote from you, Mr. Meyer, saying that automation secures jobs and automation secures locations. That sounds like quite the opposite. So are you destroying or securing jobs?
Yeah, if you look at the past, let's say the last 3 or 4 years, you can see that we haven't let anyone go, although we're now quite highly automated, especially in the area of milling. What I've already mentioned at the beginning is that everyone is talking about the shortage of skilled workers. In the last 2 or 3 years, everyone has heard about it, but somehow got away with it. Meanwhile, it has become a major challenge for companies. When we lose a skilled worker, it takes months to replace him. If you want to secure the location, or even the future of the company, the question will no longer be about how you produce, but rather, if you still have people to produce the anything. Let me break it down for you. You're looking for employees and can't find any. Your customers demand products from you, and you say, "Well, I can't get any staff, so I can't do the milling." Therefore, what I'm saying is that with automation, you can still manufacture parts. The issue has been around some time, as you mentioned, but it mostly concerned large companies. Now it has reached a level where also the smallest companies are affected. It doesn't have to be an automation system like the one behind us. It could simply be the extended running times. And our staff member looking after the system, the one we saw earlier in the film, is a young employee. Young employees are looking for an attractive workplace. They no longer want to work 3 shifts. We've been able to change that, but meanwhile, we're at a point to say, no one wants the second shift either. Young people have a social life. They like to enjoy their freedom. Today, a job involving working 2 shifts has become unattractive. There are many factors playing a role that force us to act. We also have to consider that we do not only have a location in Germany, we also have to compete globally. And that's the only way forward. I'm convinced that throughout the next 15 years, only those companies will be or remain successful that are able to manufacture certain parts in unmanned operation, not those that let people go. It's precisely the other way around. You first have to find someone to hire. I agree. We have a lot of discussions with customers, and they never say that they're automating to save manpower. That's not what it's about. What it's about is that young people want an attractive workplace. People no longer necessarily want to work 3 shifts. We hear it quite often. I want unmanned production so I can run the automation myself at night. I can run it into the weekend without needing any staff. These are the most common approaches and topics right now. There is another aspect. Let's say I'm using a certain piece of equipment in production. Spindles, for example. With the staff available, I can operate the spindle for 1 shift, but then it will stand still for 2 shifts because there's not enough staff. With automation, you actually want to utilize the spindles as much as possible so that the company can calculate the hourly rate on a reasonable basis. As a result, 1 spindle replaces 3 machines because when automated, it can be run in 3 shifts. And that brings us back to the topic of securing locations. I think that's where it all comes full circle. As we said, we automate reliable processes. Let's figure a young person with a top qualification, age 25 for example. Would that person really be interested in a job where all of this had to be done manually? What I mean is having to load 100 parts every day. I'd not be able to hire any skilled worker for that kind of work. So we're taking these processes out of the hands of the skilled worker and automating them. Then, as we said, there are processes for which you need the staff's know-how. Processes that cannot be automated. I'm exaggerating now, but we need to use the few employees we still have for those processes that require the know-how of people.
Here we have a fully automated process, but we're also talking about partial automation in the future, right? You don't have to start at 100%.
That's correct. I'd recommend companies to start with an approach making it easy for them to gain synergies from automation, to get started that way and then to develop things further afterwards. Of course, the more you automate a process, the flatter the effect curve will become. Partial automation can mean pallet automation with a clean and simple interface. Workpiece handling automation, as we have here, is much more complex and requires more preparatory work. This is because every type of workpiece handling, gripping of the workpiece, reclamping, insertion, as well as additional processes such as regripping or deburring or conservation processes, probably the easiest to implement, are really different for each component. And that's where it really gets down to the nitty-gritty and becomes more time-consuming to properly coordinate the process in the preparation stage in order to design the automation.
I've learned that very little in this context is available off the peg, that we really have to design customized solutions. Is that also something that puts some people off? We just talked about the time factor and so on. Is that the reason why some say, I'd rather not tackle it? Could we not simply get an off-the-peg solution and off we go?
Companies like standard solutions, and sometimes they are also lured with standard solutions. But when you get into the nitty-gritty and listen to the customer, you start to realize that the process does not fit what is actually defined or presented as a standard solution. I don't think I've ever had a customer where I was able to say, okay, take the standard solution. That's exactly what fits you, because every case is different. Yet generally, I would not put it as harshly. Not everybody is offering standard solutions. There are many standard solutions on the market. For standard solutions, you have to have standard parts. For example, if you have these iron blocks that are always machined in the same way, a standard solution might be a fit. But as Mr. Weinhold said, if you really want to make a leap forward and get ahead, the standard solution usually doesn't work anymore. A standard solution works when you're willing to compromise. Well, Christian is a guy whose head is very deep in the technology and the machine. And he was the one to bring us down to earth. That was also important for me. We're not an automation company, and we're certainly not the smartest people in the whole Allgäu region. And when we no longer understand the process we're discussing at the table, then we have to stop. The customer has to understand the process. What are we going to do then? We can have illusions and say, that's how we want to produce. And then Christian says, sure, you can do that, but then we'll need this and that. And at some point, you no longer get it. You must be able to understand a process, even an automated one. And when you understand it, it's relatively simple, and then automating is fun. In principle, you could say that we haven't completely reinvented the wheel here. The design of the robot cell always looks the same, more or less. It comprises the robot, loading and unloading of raw parts with a re-gripping station, a blow-off box, and a gripper station. It's the same for many projects. But it's the details that make the difference. What does part infeed look like? Where do the raw parts go in? Is there an SPC drawer? What is the strategy behind this? What's the NOK strategy? What does the re-gripping station look like? What does the gripping station look like? Is there an immersion bath? What's happening at immersion bath? And that's already 10 different options that are not part of a standard solution. I have to look at them explicitly and specify them. I believe the issue sometimes is that the way companies interested in purchasing an automation cell think is too complicated. When buying automation, there's always the tendency to include additional features that inflate the whole system so much that it's actually no longer manageable for the customer himself in terms of the process. Then it's time to say, let's come back down. Let's focus on the key tasks. And if there's still room to maneuver, then maybe we can go one step further. I think that's a better approach compared to starting off with something too complicated. I think that we have all experienced it ourselves. I mentioned it before with the mobile phone or software. When you get an update for Windows today, it's complex, complicated. You find that you have to relearn many things. And with processes, it's the same as with the software. That's something that you can relate to. For a solution to be successful, people have to understand it.
Let's take a look into the future before we get to the questions. I know you are not crystal ball readers, and it's probably not even possible to foresee the next 2 years in times like these. Still, I'm asking you, where are we headed? What's the direction for ALLMATIC in the future? What do you think is the future of such systems in general and as far as you're concerned?
From the ALLMATIC point of view, I have to say that we've started to take a new approach recently. We'll start by developing our products mechanically so that we have really good, high-quality products. And these products must be equipped with electronics incorporating sensor technology. We presented some of them at the trade fair. We now have sensors integrated throughout these products. We can record data. We can perform measurements. That's the first step for now. In the future, the second step will be that our products must be able to send data. For example, clamping force data to an app or to a machine. And going forward, let's say in 4 or 5 years' time, we have to be at a point where in systems like the one behind us, every component is able to communicate. That means it will no longer be enough for the ALLMATIC tombstone to signal a problem with the clamping force. We must be able to pass on the information to Fastems. After all, you have to keep in mind that there will be no one here in the hall to intervene. Then we need a flexible reaction, or Fastems needs to react. ALLMATIC sends a signal to Fastems that Fastems recognizes. Either there needs to be a fallback strategy, or I have to shut down the system. To me, that's the future. A complex future in which all of a system's components communicate with each other digitally. That's where ALLMATIC has to go and will go.
Where is Fastems headed?
ALLMATIC already described the principle. In manufacturing, we are on the road to digitization, which is being developed further and further. The aim is to collect more and more data. On the other hand, more and more data is transferred from the higher level into manufacturing in order to make the processes more stable and to bring about a continuous process of development and improvement. Regarding the hardware, it's basically always a question of the workpiece and the machining processes. Then there's the master control. That's a topic that is being further developed and driven forward by Fastems. For example, to include more data from the clamping fixture and to be able to ensure a more stable process in the automation.
Same question.
Most of the questions have already been answered. We as a machine manufacturer, especially as HELLER, have to place a greater focus on automation solutions. The days of selling standalone machines is over. Our priority lists are full of automation requests. That's the trend. That and the topic of digitization. Everything will become more interconnected. Communication has to be improved. With the connection of MES systems and ERP systems. In the future, this will not only be implemented in manufacturing systems, like the one we have here, but throughout the entire shop floor. It could also be manually clamped workpieces in principle. Basically, the master computer could specify the clamping force to apply for closing the vise, for example. You already have a manual screw unit here in the program. It's really about starting to standardize interfaces for such data and being able to transfer them to other systems using a simple, tested method. This brings us back to the topic of standard solutions that customers like to have.
And that's what has to fit on a beer mat at the end of the day? Because I'd like to come back to what you were referring to at the beginning. Something about a beer mat?
That was at the weekend. Yes, the beer coaster, we already mentioned it. HELLER's sales representative, Mr. Langer, actually presented the first design version, basically sketched on a beer coaster, asking me, "Thomas, could you imagine building a cell like this?" That was it. And my reply was, "Yes, sure, but let's sit down and talk about it first. Bring the beer coaster. It will be our starting point. That's why I'm saying we can go from a beer coaster sketch to an automation solution. It doesn't matter what you start with. The main thing is that you can implement it and understand what you want. And beer always helps."
And what about these thick planks you mentioned in the opening statement?
That was a bit of fun. Well, it has two backgrounds. Here in the Allgäu region, we often say that sometimes you have to drill some thick planks, which means you have to stick to it until it's done. Any controller will be tearing his hair out now, but what I'm trying to say is that such systems, such visions, cannot be calculated to the last euro. Many inventions in the world today certainly don't exist because they were calculated down to the last cent. It also takes courage. And you also have to, as we say, drill some thick planks. You have to break new ground as well. Of course, there are defeats you have to deal with, but if you never take a risk and never really break new ground, you will ultimately achieve nothing. I cannot say this for sure, but I think it's the same with our partner companies. I think at the beginning, none of us knew how the system would pay off. Despite all this, we decided to go for it. We chose to take a new path because it's a new development. That's what I was referring to with the first plank. And the second plank really symbolizes the cooperation. Of course, you can compare every single euro in the quotation stage, and our companies are probably not exactly known for being the cheapest in every aspect because of the quality and level of service we offer. You can see that when mistakes happen, also on our side. For example, when the system was up and running, the robot crashed into the HELLER machine's safety guarding. The robot damaged the complete machine housing. As a result, we were no longer able to produce. But within 1.5 days, ALLMATIC, HELLER, and Fastems managed to fix some wooden planks to the machine onto which we screwed all the sensors. The next day, the system was up and running again. until we got a new housing a few weeks later. And that's what I'm saying. How are you going to measure that in advance? Of course, there are manufacturers who are €5 cheaper, but we never spoke about money until we had solved the problem. That was the story with the planks, a situation we really ended up using wooden planks in mechanical engineering, in automation, to make unmanned production work again.
Gentlemen, a very fascinating topic. The director signals to me that we have some questions from our viewers. I'd like to answer some of these now. I don't know what they're going to be, but let's just have a look. Let's see which questions we can answer. What are the maximum autonomy times of the cell? Who can answer that?
Let me answer this from practical experience. And then the automation and machine manufacturers can share their view. At the moment, we can really produce around the clock. But often it depends. There's no need to fool yourself. The system is not always running. There are influencing factors. When a chip gets stuck or when the raw material is not entirely clean, occasionally we have breakdowns causing the machine to stand still. But from the technical point of view, as you can see while we're talking, it's constantly running. We can run the system around the clock, including Saturday and Sunday. Autonomy time, in principle, is an elastic concept. It depends on the components that are machined and the cycle times. What is interesting, however, is when you're thinking about automation, you also have to think about the willingness to make organizational changes at the company. You no longer have an 8-hour shift model. It could be 5 hours maybe, and then the employee can go home because the machine will continue to run for 5, 6, 7, or 8 hours. Then staff comes in to get the machine ready again for autonomous operation to continue. So you can't make a blanket statement. Every cell is different. It depends on the product portfolio. Some components have a longer running time than others, as Thomas Weinhold said. You could perhaps come in for half an hour on a Saturday afternoon, replace the raw parts, and then autonomous operation can continue for another 7 or 8 hours. But that's something completely different compared to having staff work all day on Saturday or Sunday. In the end, it's as I mentioned before. That's how we set it up here with the tombstones. We're using multiple setups. That means we can clamp so many parts that a cycle can run for at least 3/4 of an hour. And as Thomas Weinhold said, that's what makes a workplace attractive. At the moment, our employee looking after the periphery with the tool setting needs 7 or 8 hours. If he comes in at 10 in the morning or at 4 in the afternoon, it doesn't really matter to us. That's why the automation makes it an incredibly attractive workplace for young people. And of course, what you referred to, there are 2 phases when the machine is standing still. Then the employee should be ready to load the machine. We're very flexible, and so is he. And once the machine has been loaded, we can let it run for a really long time. I think many customers are taking the right approach by saying, I have staff that are responsible for the cell. They have to organize themselves on the premise that the machine, the spindle, must be kept running. It doesn't matter at what time staff come in, but the autonomy time must fit the bill. And everybody is happy when the boss is happy because the spindle is running. Or aren't you happy? I'm definitely happy when, at times, I walk through the hall at the weekend and the machine is running. Of course, I'm not always here at the weekend. I have a family too. Hello to them. But it's a great experience, and you really know you've made the right decision when you come here at the weekend. There's no one around, and the system is producing. It's just a sense of achievement.
On to the next one. How do you know that the system is running smoothly? We touched on this very briefly before.
Yeah. When we put the system into operation, we initially monitored it for half a year over 24 hours with a camera. So we would know if there were any errors. We then eliminated these errors. In the meantime, thanks to our Fastems master control system, we have the information delivered to the PC in the office. Staff also get a message by email or mobile phone in case something's wrong. So the question really has to be the other way around. How will I know if there's a problem? Because if I don't get a message, the system is running.
Exactly. Our next question is, what is required of the robot in terms of positioning accuracy?
Again, this depends on the clamping concept and the workpieces. Ultimately, we depend on the accuracy of the robot. Basically, it's at the heart of the system as it handles and loads the workpieces. The accuracy must fit the clamping concept and the clamping fixture itself. The robot cannot be adjusted because it has set tolerances. The vise provides the advantage that I can insert the workpiece, and basically, the vise does the closing movement. There we have certain movements involving the robot. We're talking about a few tenths, but not the range of a millimeter. So, normal visual judgment. So if Mr. Weinhold talks about vices, then I guess I get to talk about vices as well. We have the advantage that our robot's positional accuracy is not important for us. We have a drawdown effect with our clamping fixtures. This means that the robot places the part into the vise, and the vise pulls the part into position anyway, due to the drawdown effect. For the second setup, we are using a measuring probe to check the position, and the probe transfers the information to the machine, so it knows the part's position. That's why positioning accuracy is not really an issue for us.
And the next question, was there a pneumatic or hydraulic alternative that would have fit your requirements?
Yes, I'm sure there is. Depending on which parts you're machining. In the end, it was not an option for us, because hydraulics simply cost a lot of money. I really need the hydraulics outside on the table. And you would have to equip every clamping fixture with hydraulics. The benefit of the alternative solution, using our screw unit, is that our clamping fixtures are still mechanical, and the screw unit always operates one clamping fixture at a time. The problem with the pneumatic alternative is that you are always losing clamping pressure. And using pneumatics now also poses an energy problem for systems running 24 hours a day. Pressurized air costs a lot of money, and therefore it was clear to ALLMATIC that we needed a new solution, not an existing one. I would also say that hydraulic clamping fixtures are less flexible than mechanical ones. Definitely. They are tailored to a specific workpiece, and therefore spent a lot of time as stock items, because I will not always be able to use them or always want to use them due to the variety of workpieces the company has.
Let's take a look at the next question. What's your strategy in terms of rejects?
I'll explain from a practical point of view how we handle it. Although I think Fastems offers many ways to deal with rejects, the goal is not to produce rejects in the first place, of course. We prevent this by measuring all parts with probes. So every component that goes in there is scanned with a probe. If it turns out that we have a reject, the system transfers it to what we call a reject drawer. From there, staff can remove it. Instead, we use a measuring probe to determine if something is out of tolerance. The data is then transferred to the machine, and the machine corrects the dimension independently. But I think there are many more options to choose as a strategy. There's one thing that you can see very quickly in case of a bottleneck. The fact that an automation solution is not a human being. When you have a tool breakage in the machine, staff is able to decide if the workpiece is still okay. In principle, you could run the NC program again. So you would not have a reject at that point. An automation system just goes by the concept. The machine sends an error message, NC program terminated. There has been an error in production, so the only thing you can do is to remove the part and to put it in a testing drawer. If a staff member is available, then he has to check the part to see if it's still okay or not. Different approaches are discussed, though. Some say, why don't you put in a sensor here and there to provide the automation with the kind of sensitivity that staff has? But no one wants to pay for that. There is no standard. Every customer has different requirements. We are dependent on staff. Excuse me for cutting in. We talked about the topic of saving manpower earlier on. We need staff. We need their skills. Skills an automation cell cannot have. Definitely not.
How do we ensure that the parts are always properly clamped?
I've already halfway answered this earlier, but again, with our clamping system, we have a pull-down effect. This allows us to securely clamp the components. And the crucial element is the measuring probe. By now, we have longer running times because we didn't have a measuring probe in the past. We had people checking and correcting the parts. But you can't automate when you're doing it like that. We accepted to have longer process times because we measure every part. But it's still worth it, because that way we make sure that every part we deliver is a good part. But we couldn't do it without a measuring probe.
Let's look at the next question. This one's also very interesting. Can you also automate an existing machine?
Yes, of course you can. But you have to be clear. What is it I want? There are automation solutions like the one we have here. There are interfaces for every machine that can be retrofitted. The question is, what kind of automation do you want? A classic pallet handling system or a robot cell? Do you have a master computer or not? Do you need clamping hydraulics or not? Do you have a solution with a screw station? But in principle, it can be retrofitted at any time. There have been approaches and many projects where existing machines were automated, but rather in terms of pallet automation, but also workpiece handling processes, yeah. There's one thing you have to accept. You can purchase a used machine on the market, but to complete the project successfully, you need a partnership. An automation supplier can and will not convert, for example, a HELLER machine by himself, meaning without HELLER, in a way that is suitable for automation. That is because of the interfaces, safety issues, and so on. Again, this requires partnership. That brings us back to having a general contractor. But the question is interesting because ALLMATIC is actually working on the same topic. What will we do with the existing machines? We are quite far into the process of launching new vices that are electrically operated or battery-driven. With self-sufficient clamping fixtures, you can automate existing machines more easily. This is an important topic for us as well because there are many existing machines. A HELLER machine, for example, can be at a company for maybe 15 to 20 years. You can't keep investing in new machinery. This is a major topic. It's a legitimate question. We have to think about the existing machines as well. But the market is hesitant at the moment.
How long did it take you from the first discussions to order placement and implementation into ALLMATIC's processes?
Oh, I'm almost too old to remember that. I don't dare say it honestly. Well, I'll make a rough guess. As I said before, it took me 4, 5, 6 months before I was sure about my process. Then we spent some time talking to people in the market. I'll deduct that time because HELLER and Fastems weren't involved at the time. But then we met the right partners. And then for, let's say, 1.5 years, we did the following. First of all, we put the HELLER machine into operation. We revised all the processes, all the programs, ran them in again on the HELLER machine. And only when HELLER and ALLMATIC were clear about the process, we finally put the automation on top. This is how we did it. You mentioned before that we said we'd rather do it step by step. Prepare the machine, run in the processes, and then add the automation. Because what we have here is a major project with all the equipment and all that the system can do. Therefore, you cannot deal with everything at once, the machine and the system. That's why we did it separately. We also had to be considerate of the human factor. We have to understand that. But to answer the question, I think it took us 2 years. Yes, from the initial meeting to completion, 2 years before it was completely finished, yep. Well, we also talked about some pointless things at times, so we can deduct a few days, but in total I would say 2 years. 1 year and 361 days. But in order not to scare our audience, we have to say it usually doesn't take us 2 years to prepare a quote for a project like this. But it must also be clear that we can't do it in 14 days.
Maybe this is a stupid question, but with the level of knowledge you have today, if you were to tackle such a project again, what would be a more realistic figure? Can you make an estimate? How long would it take?
That very much depends on how far the end customer is. That is crucial, really. Has he already given it some thought? Does he already know what exactly he wants? Or has he not looked at the options at all? But anything less than a month is not realistic. It will take about 4 weeks, even if the customer's already put some thought into it. What takes up a lot of time is defining the process. Defining and designing the clamping fixtures in order to be able to assess how this kind of automation can be realized at all. When you come to the point where you can say, yes, we can imagine a process for this, it will not be possible for each party to start off immediately. First, one party needs to do the preliminary work before the other party can take action. And then you go back and forth to clarify the questions. It's a continuous dialogue, and whether it takes 4 weeks to the first quote or 6 months depends on where you are at that point and where you're headed. What details need to be coordinated before you can go ahead? I wouldn't want to make a blanket statement about this because it's the same as with digitization and automation. These are buzzwords that are not defined. They mean something different to everyone, and that's why it's difficult, as Christian said. It can be a highly complex system or a very simple one. Therefore, it can take 4 weeks to 4 months before it can see the light of day.
But at least that gives us an idea of the time frame.
There are also timelines that stretch over years.
Depending on complexity.
Market situation, volatility of the customer, there's a wide spectrum.
Well, next question. Does this robot cell incorporate a master controller or PLC?
What is extremely important with this cell is that we are using the full MMS master computer software. It's not a conventional robot cell that handles a part with all of the programs stored on the machine and traditional program selection. Instead, we have an NC program transfer. We have tool requirements analysis, which makes everything much easier, and which, of course, is necessary for unmanned production. You can't have the system running 2 hours during the night shift, only to find later that tool life expired. With the corresponding software options, I can check in advance whether the project will run to the end, whether batch sizes can be machined without tool life expiring. I think that is really a key part of the system. Yeah, when we have a staff member working on the system for 8 hours, the system must be able to tell him what it will need throughout the next 16 hours. And we have to be able to do that with the software in the end, so the employee knows exactly what he has to do to keep it running for another 16 hours in unmanned operation. This is also a learning process. Staff are overwhelmed at the beginning, trying to figure out what they need to do. Now I have to do this, now that. It's a learning process. You have to grow into it. The higher the flexibility of an automation, the more important it is to have a master computer as the interface to the employee. Staff themselves are no longer able to assess the flexibility, the variety. Otherwise, they start using Excel tables on paper again that are filled in manually in order to help them remember what needs to be done. That brings us back to the topic of digitization. For that, training is extremely important. Many customers do have a master computer, but if they don't use it to its full potential and don't even know what they can do with it, we've seen this many times before. People come in for training and afterwards they say, if I had known that it would work this way or that, I could do that. That's another important point, providing reasonable training for the systems. I'd like to make a general point. Automation can only ever be a tool to the customer to take his production further. How the tool is used cannot be determined by an automation supplier. I think ALLMATIC understood that and knew how to use it. Thank you.
And let's leave it at that. We will be happy to answer any further questions you may have that we were unable to get to during the live broadcast by email. I really enjoyed this. So many new insights. Thank you very much to my guests. Thanks to ALLMATIC for letting us host the event here. And of course, we sincerely hope that you at home or wherever you are watching have found the information useful. And we are pleased if this topic is of interest to you. I'm sure you will have noticed that the partners here know what they're talking about. So if you have any similar ideas, anything lying in a drawer that you would like to tackle, now you know who to speak to. Thanks for watching. See you next time.